Okay, this will be our second lesson on solving systems by graphing. Okay, all we do is we take our equations and we graph them twice on the same plane and we see where they cross. In this video, we'll recall how to graph horizontal lines like y equals 3 and vertical lines like x equals -2. We'll explore systems with 0 solutions, 1 solution, or infinite solutions, and we'll handle the word problem, probably. I've not been stressing this very much, but I should. You should be taking notes that you can refer to, either on paper or iPad, where we're going to talk about no solutions, 1 solution, infinite solutions, and I'll draw an example and I'll give scenarios. You should be copying these down. You should have a place you can refer to things so you can learn from them beyond just trying to find my video again. Remember from our last video, a system of equations is 2 or more related equations, and we can find the point that works in both equations by graphing them and seeing their point of intersection. So I'm going to solve this system right here, x minus 4y equals 8. I'm going to start with this line. This is x equals. If you have an x equals something, like say it was x equals a, that is going to graph as a vertical line at wherever a is. It's like if this is point A right here, that's an x equals equation. X equals graphs with a vertical line, not a horizontal line. A lot of people think, oh, x equals -4, and they go, okay, x equals -4 is right here. And then they say, and it's the x-axis, so there it is. But if that were the case, if that's how that graphed, then x equals -4 would graph the same as x equals 2, because 2 would be here, and you would draw that line. And every x equals thing would all be the same, which doesn't make any sense. So here's how I think of it. This is asking the question, where is the x value -4? Where does the x value equal -4? That happens right here at -4, 0, yes. But it also happens right here at -4, 4. There the x value is -4. And also at -4, 6, and at -4, -5, and at -4, -1.5, and at whatever this point is and this point. It's all of these points. An x equals equation is a vertical line. Its slope is undefined. There's no slope. Okay, next I'm going to graph this line right here. And I should just specify, I guess, while we're talking about it. I want to go back a second. So then also that means a y equals is a horizontal line. Like say this is my coordinate plane, and this is y and this is x. I'm going to graph the line y equals a. Well, that's going to happen here if that's where A is. If this is the point A, it's a horizontal line. So x equals is vertical, y equals is horizontal. This is the sort of thing you should be writing in your notes somewhere that you can refer to. In fact, I would put it someplace like on the wall behind your computer where you work so you can look at it. Like have a page of math notes you can just refer to very easily without having to flip to them or without having to like wonder where they are. Okay, let's graph x minus 4y equals 8. This is in standard form. The a value is 1, the b value is -4, the c value is 8. To get the x-intercept, I do c divided by a, which is 8 divided by 1, which is 8. I can't fit 8 on here very well. I'm just going to put it out here and hope for the best. It's probably more like out here, actually, 8, 0. Let's find the y-intercept. To find the y-intercept, you do c divided by b, which is 8 divided by -4, because the negative sign is very important, so that's -2. And then the slope is c divided by a. No, it's not. I'm a crazy person. The slope is -a divided by b, which is -1 divided by -4, which simplifies to 1/4. So from here I go up 1, right 4, up 1, right 4, and also down 1, left 4, down 1, left 4. This line graphs like this. Now the point of all this, I'm solving this system. So I graph the two lines and I want to see where the two lines cross. This system has a solution at the point -4, -3. That is my solution. I'm going to say that the solution x comma y is in the set -4, -3. Now to check this, I'd have to plug this point into both equations. However, plugging it into this equation is really simple. Here, x equals -4. Here, x equals -4. Sweet, I checked. That one's good. That one works. Let's check the other one really quick. It has an x and a y, so I plug in two things. Negative 4 minus 4 times negative 3, does that equal 8? Negative 4 plus 12 does equal 8. Sweet, it checks. There's my solution, negative 4, negative 3. Okay, remember, x equals vertical line, y equals horizontal line. Okay, consider a system that has no solutions. How does the graph of this system look? If something has no solutions, but there's two equations, like you have a system with two equations, like let's say we have y equals 2x, which graphs like this. What does it look like if there's no solutions at all? Well, that means the two lines have to be parallel, which means they must have the same slope. If two lines have the same slope, but different y-intercepts, for example, this has a y-intercept of 0, this just y equals 2x is the same as y equals 2x plus 0. If they have the same slope but different y-intercepts, they're never going to touch, because one of the lines is like this, that I just drew real poorly. The other line is like this. And because they have the same slopes, they will never ever touch. They're parallel lines. Parallel lines have no solutions. Okay? A no solution set, we can also write like this. This is called the empty set. It's also called nil or null, especially if you're British. But that means there's no solutions. There's no point where these two lines cross. They're parallel lines. To be parallel, you must have the same slope but different y-intercepts. We call this system inconsistent. If you ever hear that there's an inconsistent system, that means it doesn't have any solutions, it doesn't make any sense, it doesn't work. Okay, parallel lines have no solutions, empty set. There's actually three possibilities. There's crossing at one point, crossing at no points, and finally we'll do the third. What do you think that third possible scenario is? Okay, I'm going to graph this in pink. 2/3 x plus 4 up to right 3, down 2, left 3, down 2, left 3. It's this line right here. This is the line y equals 2/3 x plus 4. I'm also going to graph this line. This has an x-intercept at 12/2, which is 6. Y-intercept at... Oh, let's change this. This is supposed to be a negative 12. Yeah, I'm going to change this really quick. So Grant, go back and edit this. I'm going to make that a 2x minus 3y equals negative 12. I hadn't typed that correctly, so I'm just going to fix it real quick. I'll graph this one in a nice bright green. The x-intercept is negative 12 divided by 2, which is negative 6. Here. The y-intercept is negative 12 divided by negative 3, which is positive 4. Here. The slope is negative 3 over negative 2, which is 3/2, which is here and here. This is the same line twice. Same line twice. If it's the same line, it intersects everywhere on this line. It has an infinite number of solutions. So we say the solution set is all real numbers. X and Y are both in the set of all real numbers. And that fancy R, it's an R with another line through it. That means all real numbers. We would call this set consistent and dependent, meaning there are solutions, but it depends on what your x value is. If your x is 2, it's 5. If your x is 4, it's whatever that value is. So we would say consistent or dependent, and this means it has infinite solutions. There's an unlimited number of solutions. If two lines have the same slope, they will either form a system that is inconsistent, meaning there's no solutions, or one that is consistent and dependent, meaning there's infinite solutions. If you have the same slope, it's either the same line twice, or it's two parallel lines. If the slopes are different, then two lines are guaranteed to cross somewhere. If slopes are different, the lines will cross somewhere. You find that solution. So there's really three options. There's parallel lines. Parallel lines if you have the same slope at different y-intercept. This has no solutions. There's the same line twice. If it's the same line twice, it's crossing a whole bunch of times, and that's infinite solutions. Or there's just two lines with different slopes that cross somewhere, and there's one solution. We would write that solution as, like, say this was the point negative 1, 4. We would say x comma y is in the set negative 1, 4. Those are three options. This is another page you should put in your notes so that you know there's three scenarios and how they come up. Parallel lines, no solution. Same line twice, infinite solutions. Two lines of different slopes, one solution, one point of intersection. Okay, here's a word problem for us. Sarah can knit 2 scarves every 6 hours, and she's already made 5. Doug can knit 1 scarf every 3 hours and has already made 4. In how many hours will they have the same number of scarves? Well, you'll notice I didn't even draw a plane for this. I'm not going to try to graph this. Because if Sarah can knit 2 scarves every 6 hours, and I can write the word scarves, don't worry. That's the same as 1 scarf every 3 hours. That's the exact same rate that Doug works at. Sarah and Doug are working at the same rate. They have the same slope. However, they started at different points. She's already made 5, but Doug has only made 4. They will never have the same number of scarves. This is a situation of no solutions. Parallel lines. 2 lines are going to have, like, one line goes like this, one line goes like this, but they ain't never touching. Okay, that's it for today. Nice work. See you next time.